This module covers supporting systems. Upon completion of this module, you should be able to identify characteristics of the climate control system and characteristics, components, and service of the braking system. You must pass the test at the end of this module to receive a completed status. Select the next active link to continue. The climate control system regulates temperatures inside the cabin of the plug-in hybrid electric vehicle, or PHEV. The multi-zone automatic heating, ventilation, and air conditioning, or HVAC system in the PHEV has been modified from the conventional system found in non-hybrid variant vehicles. The unique components of this HVAC system include a high-voltage heater, a high-voltage air conditioning compressor, and a drive motor battery chiller. The air conditioning compressor in the PHEV runs on three-phase alternating current from a high-voltage electric motor. The power inverter module converts high-voltage direct current from the hybrid battery into alternating current for the electric motor. The air conditioning control module commands the operation of the high-voltage compressor, which requires pure polyester oil. Contamination from other types of oil may lead to a loss of isolation when high voltage transfers to the low voltage system through the refrigerant oil. Therefore, a good policy is to have dedicated equipment to service the air conditioning system of the PHEV. If dedicated equipment is not available, the service lines must be flushed of oil to prevent cross-contamination. The internal combustion engine and a high-voltage electric heater called the Coolant Heater Control Module, or CHCM, provide heat to the passenger compartment. The CHCM is used when the engine is inactive or when the engine is cold and passenger compartment heat is requested. The heater provides different levels of heat depending upon the quantity of heat needed and the outside temperature. The HVAC module activates the CHCM via serial data. A heated 50-50 mixture of Dex-Cool and deionized water from the engine or from the CHCM is used to meet the HVAC temperature demands. A passenger compartment heater coolant control valve commanded by the Hybrid Powertrain Control Module 2, or HPCM2, controls the coolant's flow. When the engine is not running, the valve directs coolant through the heater. When the engine is running, the valve directs coolant through the engine. Select the next active link to continue. The Cadillac CT6 PHEV blends regenerative and friction braking to provide optimal energy recapture and stopping power based on driver demand. Regenerative braking utilizes the drive motors as generators within the transmission to recapture energy that is traditionally wasted during braking or coast down. The resistance created by the drive motors during the energy generation process slows the vehicle. The hydraulic disc brakes work with regenerative braking to ensure effective overall vehicle braking. The Electronic Brake Control Module, or EBCM, interprets the braking request and uses regenerative braking, conventional friction braking, or a combination of both as necessary. The vehicle incorporates the Bosch ESP HEV braking system. The brake pressure modulator valve, electric brake booster, and master cylinder are designed to work with electric vehicles that utilize regenerative braking capability. Other hydraulic brake system components are similar to a conventional vehicle. The brake booster assembly works similarly to a standard vacuum booster, except that brake boost is provided by an electric motor instead of engine vacuum. To balance the brake pedal feel for the driver, booster braking force is changed to match the brake fluid pressure in the system. A blended braking strategy mixes friction braking from the base brakes and regenerative braking from the electrical system. During the blended braking process, the EBCM and the HPCM1 constantly communicate to determine the appropriate combination of friction and regenerative braking. The system makes real-time adjustments to the blend to achieve optimal braking performance and efficiency. If an electrical or hydraulic failure occurs in the braking system, the system enters fail-safe mode, where the brake pedal depresses closer to the floor than normal and the master cylinder actuates directly. Base brake bleeding on the Cadillac CT6 PHEV is similar to a conventional vehicle. However, you must use pressure bleeding techniques. Do not attempt to manually bleed the base brake system by pumping the pedal. To begin the process, you must relieve pressure from the brake pressure modulator valve and the high pressure accumulator, or HPA. The automated bleed procedure must also be completed. Always follow the steps as stated in service information. You must use the CH29532A pressure bleeder or equivalent, along with the CH35589A cap adapter, with at least 3 liters or 3.2 quarts of brake fluid. Do not pressurize the bleeder and thereby the master cylinder reservoir until prompted to do so by the scan tool. Use a 20 ampere output battery charger to maintain at least 12 volts throughout the procedure. The electric parking brake system has actuators that are bolted directly to the rear calipers. The rear caliper actuators are controlled directly by the EBCM. The actuator meshes with a threaded rod that moves a ram out against the piston. When servicing the rear brake pads, the scan tool must be utilized to retract the ram, allowing the piston to be pushed back into the caliper bore. If the electric parking brake actuator fails, or if there is a loss of power, the parking brake may be released using the following procedure. Remove the parking brake actuator. 2 5mm Allen bolts hold the actuator in place. Insert the Allen key past the splines in the caliper. Inside the caliper is a machined 5mm Allen recess that allows the Allen key to fit. Turn the piston clockwise to release the parking brake. Turning the piston counterclockwise applies the brake. This module covered supporting systems. You should now be able to identify characteristics of the climate control system and characteristics, components, and service of the braking system.